Input-output management functions. An operating system will have device drivers to facilitate the input-output functions involving the input-output devices. These device drivers are software routines that control respective input-output devices through their controllers. Their operating system is responsible for the following input-output device management functions: keep track of input output devices, input output channels. This module is typically called input output traffic controller. Decide what is an efficient way to allocate the input output resource. If it is also be shared, then decide who gets it, how much it will be allocated, and for how long. This is called input output scheduling. Allocate the input output device and initiate the input output operation. Reclaim the device as and when it is used is through. In most cases, input output terminates automatically. Process management functions. A process is an instance of a program in execution. While a program is just a passive entity, process is an active entity performing the intended functions of its related program. To accomplish its task, a process needs certain resources like CPU, memory, files, and input-output devices. In multi-programming environment, there will a number of simultaneous processes existing in the system. The operating system is responsible for the following process management functions. Provides the mechanism for the process synchronization for sharing of the resources amongst concurrent processes. Keep track of processor and status of processes. The program that does this has been called the traffic controller. Decide which process will have a chance to use the processor. The job scheduler chooses from all the submitted jobs and decide which one of the all allowed into the system. If multi-programming, decide which process gets a processor when, for how much of time. The module that does this, called the process scheduler, allocate the process to process by setting by the necessary hardware registers. This module is widely known as the dispatcher, providing mechanisms for the deadlock handling. Reclaim the processor when process ceases to use a processor or exceed the allowed amount of usage.